Alrighty, quick sound check here. Gotta make sure I'm on the correct microphone. Actually, I know I am, because I muted the wrong one. Okay, good evening, everyone. Welcome back to Coding Together. This is a weekly live stream in which for 1 hour you get to get an front row seat on how a professional software developer goes about solving problems and writing code. I am recording this video on Thursday, March 30th, 2023. My name is Savanni, and I'm a staff engineer at 1Password. I learned to program when I was 12, and I became a full-time developer in January of 2000. Since then, I have been all up and down the software stack, from as low as individual logic gates, pandemic project that was quite fun, to as high as building GUIs for GTK and the web. Gonna see some of that tonight. So let's get into it. I'm gonna move my notes into place and let's check out the code. Well, not check out the code. We'll start out with my notes, actually. So tonight we are continuing with the Kifu application. Kifu is a, I believe, Japanese word, might be Chinese, but I'm not sure. Don't quote me on that. But it's a word that references a, oh, I should have had it nearby, but I don't. A written record of a game of Go. This application will be far more than that. I am certainly interested in potentially better names, but that's what I got right now. It's the naming of things is challenging. So this will be much more than just keeping track of game records. This will be about like a database of games, but also like playing against other players, whether it's locally on one device, over the internet, against AIs, and if I'm really good at it, logging into and playing games on OGS and on KGS, the two big Go networks. Or sorry, not the two. There's actually quite a few large Go networks. They're just the two that I know. Currently, I have a GTK application. Did not have that 2 weeks ago when we started this. 2 weeks ago, all I had was a design. I am architecting it knowing that I am also going to build an Android application, because one of my primary use cases is to take this when I'm playing Go, and there's actually kind of a junky game. Kind of a junky application. It works, but only barely. But so that I can record a game while I am playing in person. So let's start out with the design versus the reality. Need my browser. So file. There's the app design. Is that the correct? Let's just go there. Yeah, here we go. We'll hit the index. So this is the design that I worked out last time. I have deviated from it and instead optimized for more landscape mode. I am not yet ready to handle the difference between landscape mode and portrait mode. So I'm just really going for landscape mode right now. And I better stash what I'm working on. Git stash dash u. Or no, git stash dash u. There we go. And I have to remember which branch I was on. Oh, wow. Git add dot. Oh, yeah, all of the Kotlin stuff. I did start doing some experiments with Android. It's a thing. I know it's a thing. I can make an Android app, but I absolutely dread when I start trying to connect that to a Rust library. There we go. That worked. Okay. What are my branches? Right, feature Gobon. So the first thing I'm going to show you, once I'm done switching branches here, I am going to show you, oh, got to update the flake. I'm going to show you the, I guess sort of the widget display application. I'm calling it Screenplay, but it's basically Storybook, which you would be, if you do JavaScript programming, you might be familiar with that. It's a great application for being able to just rapidly develop individual components, view them, make all of the modifications that you need to without having to like start the entire application. Sorry about this. Didn't expect this to be a thing. Oh, wow. Come on. Come on. Almost there. Almost there. Evaluating the derivation. There we go. Okay. So let's get into source bin. Yeah, here we go. Cargo run dash x or no, run dash dash bin screenplay. Requires the right. Alrighty, so this is the screenplay application. It just has a list of the various scenes or something. They would be called stories in Storybook. I think I'm just calling them scenes. One of them, demonstration, is just a player card. I know it doesn't look good. We're not at the point of making things look good yet. But I've also got the chat area, list of messages, chat window, and then playing field. This one actually I've put a bit more effort into, but this playing field, actually I composed it from these two player cards, the chat area, big blank area, and then the actual drawing area, the Gobon itself. So this was just a really good way to like very quickly iterate over figuring out the drawing algorithms, because I would be doing development and just have I would have Cargo actually just building and rebuilding in a tight loop. So Cargo watch dash x run all of that. So it pops up, open playing field, go into the code, make some changes, and Cargo would just instantly like rebuild and restart the application. Of course, still have to go to the step of actually selecting this, or selecting the view that I want to be looking at. Not everything's perfect yet. So continuing on. Oh yeah, talking about Screenplay. Screenplay is actually available. It is a library that you then plug in. You'll build like a tiny little application and add your widgets from the library, or build a tiny little application that instantiates the library. You'll add your widgets. I'm not going to cover that tonight, but if you go searching through my tools repository, you'll be able to find it and probably just kind of figure out how to use it. So now we're going to talk about the application architecture. We're going to come back to this section as part of talking about the architecture. So let's see here. Like I said, I work at 1Password. I've been part of the 1Password 8 works, and we have, like we've talked about many times publicly, I'm not revealing any company secrets here, we built almost all of the application in Rust. So we've got all of the business logic, all of the cryptography, all of the integrating with the operating system, all of the talking to the server, like basically all of that. All of that's in Rust. And then we wrote a user interface for each one of the operating systems that we're supporting. But we went a step further. We have talked about our view model system before, but basically our design team decides on a user interface in like composable components. And then we create a core section where we describe what needs to go into that component, and then a UI component, a UI element. Terminology is a little difficult here. A UI element that just renders whatever data structure comes over. The UI has a tendency to be pretty naive. It will, whenever you click a button, it doesn't really know what that button is going to do. It just knows to dispatch that button to the core. The core will do all of the work and then respond with a new view model. I'm doing the same thing in this application. When I start out, especially as we start doing more things, you're going to see places where it's really not optimized, and eventually I will go through and figure out like different ways of optimizing it. For instance, even though the core should be defining the view model, these time clocks, the core of this application is not going to send a new user interface view model every single second in order to update the clock. Instead, it's going to send the view model which says how much time is on the clock and then just says run the clock. And the UI component will know, okay, I'll just run the clock. I can be naive about it because the core is going to tell me when to do something different. So that's where we are. Let's talk about how that is being done. Let's see here. Kifu core source. We'll go to the playing field. Failed to load workspaces. Oh dear. Hang on. I don't have a workspace file, do I? No. Oh, is Rust Analyzer going to be bad tonight? If I take that out, do I get an error? No, Rust Analyzer. Oh, yes. Okay. Rust Analyzer is working tonight. Good. Oh, that was going to be a pain. Let's go back to the playing area, playing field. So here I define everything that is going to drive this display. But I only define it at a certain level of detail. I delegate some of those details out. So for instance, we have the board, which is the Gobon element. It is this great big section. It has its own definition, which define like how many columns, how many rows, where all of the stones are. Additionally, the player card element, like this is one of these two. It defines the name, the rank, the clock value. It'll define, or it'll tell the user interface whether or not to be running the clock. I'm not doing that yet, but that's what it's going to do. But that means that a typical function inside of the core that generates the view model will take whatever data it needs. Obviously, no data in here yet. This is all hard-coded stuff. It returns the view, and then the core returns that. Makes it pretty easy for me to define all of the logical structure and then really leave it up to each one of the user interfaces to do just rendering according to the rules that get defined for a particular element. So if we're going to talk about that, though, let's actually show how an element gets rendered. And since we're going to work in it, we're going to go to the most interesting one, the Gobon itself, because this one actually requires drawing functions. Am I covering all of my notes? Close enough. Yeah, we'll come back to my notes in a moment. I'm pretty close to covering them. So a Goban contains the size of the board. These are just dimensions in terms of, oh, it's not actually in this crate. Got to go another level. The width and the height. A U8 because there's no point in using a sign. A negative value for a board size is incorrect. Theoretically, traditionally, Go is always played on a square board, so having both the width and the height doesn't make sense. But I have played a couple of interesting games that were on very strangely shaped boards. I believe one was like 25 columns by 5 rows. So I want to keep that open. So in addition to the size, we also have like what's in each one of the spaces on the board. And for this, I'm just doing a flat vector. It does mean that some of these functions for finding like the address of a point, I'm going to have to replicate in each of the platforms. I'm not happy about that, but I'm going to live with it anyway, because the only thing that will get sent across the FFI is going to be this data structure. None of these functions are going to be moved apart or moved across, and they're not going to be available to be directly called. Doing so would be very expensive. That could be a problem if I needed some particularly complex logic to have to replicate it in basically 2 different places in Rust, and then also in Kotlin. So the vector of spaces, each space contains, or each space, if it contains a stone, so most of these are none values, if it contains a stone, the information that it's going to keep is color and some jitter. Jitter is absolutely not part of the game. It is simply a feature of another Go application that like moves the stones a little bit off center in order to like simulate what it's like playing on a real board where the stones are never perfectly on center. I'm 100% going to ignore that for a good long while. I'm not even going to pay attention to this value when I'm rendering. But just know that it's one of those things that I want to put in because I just like how it looks. I like the overall feel. So having gone through that, let's jump up to the actual rendering of the user interface. So we've done stuff like this before. This is, it's a drawing canvas, again, just like the hex grid application was. What it needs to know is this actual element, and then it's going to read across the element, doing things like drawing, where are my drawing functions? Yeah, okay, so here are the places where we're drawing all of the columns. Is this the columns? Yeah, these are the columns. Drawing the widths, figuring out offset from the corner, figuring out spacing in between them based on the size of the window. Some additional work to mark out the star points. So like this point, this one, this one, this one, all of those. And then running across the entire array of stones and drawing a stone where one is present in the array. I'll admit, this is probably not the most efficient thing in the world. I strongly doubt that it's actually going to be an issue. It might not even be notable if you're like watching the performance monitor on your system, because this is not a, when it comes to processor intensity, it's not actually in playing the game of Go, it's running whatever AI, like Leela Zero or AlphaGo. I mean, none of us can get hold of AlphaGo. Like, that's what's actually going to eat your processor. But I will optimize this later if I start finding places that like don't perform as well as I want them to. The pen here is actually just a little utility class for given a context drawing particular things. It's not very important. So what I want to do tonight, actually, is where we come back to our notes. Having explained all of that, what I want to do is I want to start out by just telling the user interface whose turn it is. That's going to be almost entirely invisible at first. I'm going to change the order of this. Yeah, and take that away. So once we've told, so it won't be entirely invisible. Once we've told the UI whose turn it is, I want to render a ghost image of the stone. Oh, looks like I am getting some warnings. Not receiving enough video to maintain smooth streaming. Oh dear. I need to think about how to handle that. Supposedly I am not dropping frames, so things should be okay. My processor's down at only 20%. I think, though, I'll turn my music off. Having turned that off, no need for my headphones. Let's see here. I'm going to have to do some experiments on this. The problem is I need to keep very high resolution in order to make this legible on stream. Yeah, stream status is poor. That's no good. I need to get the chat out of the way. DVR, 360 video. Yeah, so. Oh yeah, it's doing the same thing. Okay, gonna do a little experiment here where in the middle of this I am going to reduce my resolution and then just make things larger. So bear with me as I muck about with my stream. I don't actually know how to do this. Great. Let's see. Stream capture settings. That's the monitor. I'm going to keep doing that. Oh, maybe if I turn my own camera off. So, okay, we're going to do that. Okay, so if I turn my camera off, maybe now it'll be okay. I'll have to keep an eye on things here. But maybe with like less movement. We'll make things larger though. Yeah, let's go ahead and try to change my resolution. Can I change resolution in the middle of a stream? We'll see. No, I cannot. Oh well. Yeah, I'll try to do better for the next one. Until then, we'll just continue on as it is. So let's just start out with this one, telling the UI whose turn it is. Go full screen here, come back up. And the way I actually want to do that is in the playing field. I think that's where I want to put it. Oh, I already have put it there. Well, cool, done. Moving on, we want to render a ghost image. Now, in order to do that, we have to actually figure out where the cursor is in relation to the entire board. Excuse me. Where the cursor is in relation to the entire board. So let's bail out of that. Cargo watch -x run, and it doesn't know which one. So we'll get the actual real application, which is going to look a lot like the screenplay does, and still non-interactive. I don't know if that's the best thing to do. So I'll move it over here. Of course, you can see all of the output. So let's see. So last time when we were working with the hex grid, we were looking at a motion controller. You know what? I'm not going to guess. I'm just going to look at the other app. Also in this repository. Source, main, motion. Yeah. GTK event controller motion. So let's pull up the docs for that. GTK-RS. 4. Cool, there we go. Okay, so in order to do this, we get the motion controller, we just instantiate it, we set up a connection function which does all of the calculations based on the x and y coordinate that it receives, and then set some values which other portions of the application are paying attention to. Okay, then let's do that. Oops. Yeah. Actually, alrighty, so I've got the drawing area that's been created. When did I create the drawing area? The drawing area is created as its default. Okay. So once constructed, let motion controller equal GTK4 event controller motion new. And then I'm going to want to attach that to the drawing area. Here we go. So self.drawingArea.add controller, motion controller, and then come back to here. Because I know I'm going to need to clone some things, I'll just create a block there. pause for a moment to pet a kitten, whom unfortunately you don't get to see tonight because no camera at the moment. Yep, hi. Yep, you're adorable. Good, thank you. Okay, so we're going to connect motion, and just for the fun of it, I'm going to print out the coordinates. This is going to be super slow on a machine that seems to well, I guess the network connection is struggling, whereas the CPU certainly is not. Let's get that right. Awesome. That's rebuilding. It's not happy yet. Is a event controller is not implemented for have I failed to? It's saying that I should not remove, or that I should not take a reference here. That seems not correct. How can that possibly be correct? I'm going to move this over and try not to do anything with it yet. That takes an event controller, and that does not, what? That takes a reference to something that implements event controller, and this just takes an event controller and oh. Got it. I have upgraded to a slightly later version of GTK, so the API has changed a bit. Okay, so we know, however, that should be printing things. We are totally printing things. Hang on a second. Come on, you. There we go. Kitten was sitting at my feet sulking, so put her in my lap here. Okay, so since we know where the mouse is, we also know where all of the intersections are. But I don't really want to be like, I'm going to calculate out the location of each intersection and compare that to the mouse. I'd actually prefer to go the other direction, where I start with a mouse and compare that to the intersections. This is going to require actually just doing some math here. So if I know this, so I know the location of the mouse. I want to use that to calculate the nearest intersection. So the first thing I'm gonna do, this is gonna be a very iterative process as I figure things out. We're going to first of all, we're just going to round things off. Yeah. And then I think next I'm going to subtract. Yep, there we go. Cool. Okay. So next I am going to subtract the top and left margins. So we're going to do that. Why does it not like that? Oh, does round still give me... Okay, round keeps everything in the floating point range. So now, theoretically, if I point at the upper left corner, the value that I get the value that gets printed should be 0, 0. Yeah, that's close enough. And then going off the side, I get negatives. Okay, so 0, 0. I then know that the space between is the width minus 40. Okay, right. I'm going to backtrack and explain this. Space between each of these columns is based on, take the entire width here, subtract the two margins, then you've got the entire width of the board without the margins, divide that by the number of columns. So I'm going to grab these and I'm going to start out just, it might actually be this simple, but I'm going to start out by dividing dividing by the space between. So I need to clone some variables in. So width and height. Oh, I don't actually know the width and height. Let me see what other parameters get added to connect motion. Back up. Oh, right there. So self. What can I get off of self? I don't think I can get much of anything off of it. Okay. I'm going to take a shortcut, but I think the long version, like, I know when I'm setting the width and the height too, I've got those hard-coded, but those really should not be I32s. There's no such thing as a negative width, but for some reason, GTK wants an I32, whatever. Probably I'm going to end up caching this information or cloning this information, like as part of this function call. I may end up saving it here in the Gobon private so that for board size changes in terms of physical screen pixels, that actually gets updated in a place where I can copy it around. For now though, I am just going to hard code stuff. You know, while I'm at it, I'll just go ahead and divide here too. V space between, cool. And make sure all of that's okay. Okay, good. Now I need to get self.gobon.clone, and the Gobon, I believe, is a ref cell. It's an RC ref cell, so I'm going to borrow it. There we go. That's looking okay. I need to check on things. I think this is a strong reference. Oh yeah, actually it is, because otherwise this would be data type weak. Ooh, that's looking pretty good. It's got a lot more parameters than it should, or a lot more digits than it should. Okay. 1818 00. Actually, that's pretty good. Okay, success on that. So what I'll do, let's start saving that information. Cursor location, gonna be rc ref cell. Oops. Let's create a struct adder. Row is gonna be a U8. Column is gonna be a U8. And this needs a default implementation. Clone default. Will it like that? Yeah, it's fine with that. And my proc macros are misbehaving again. That's weird. I thought I changed that parameter. Okay. Great. Now set that aside. We're going to next let cursor equal self.cursor location dot clone, and then in here let cursor equal cursor dot borrow mute actually, and now let x not x, I don't want to call it x, equal, I'm not even going to let bind this. This needs to just be that. We're going to print that. Cool. And I just got those reversed. Column, row. Save that. Things are not quite right yet. Right. So this is counting as an F64. I need to coerce it to a U8. I think I don't know that this is, yeah, no, that does not like that. I'm gonna cheat again. If you have a linter on, your linter is going to say no, do not use as coercion. It's unsafe in a variety of ways, and I know that. Okay, so we're not printing anything, but in theory, this is getting updated. So now, finally, when it gets updated, there are changes that I want to have happen. How did I do it in the hex grid? I believe, actually, was it repaint? Paint? Set draw func? No, I don't think I have an example of doing it in the hex grid. So the change happens. I want to tell the drawing area that it needs to redraw itself. So let's go ahead and, okay. So let ghost, no. I'm gonna go ahead and draw the ghost, and it should immediately appear in the upper left corner since that's the default location. So Gobonstone pen dot ghost stone context call row and color. I need to know the color. Is that right? Gobon dot borrow this Gobon element. Oh, right, not the Gobon element. It's the entire game state that I care about. Right, this thing has to be told. That's going to require some extra communication, so I'm not going to deal with it yet. I'll have to tell you in a week how I solved that, or maybe I'll do it in my write-up. I'm going to start trying to do write-ups of these right after. So we'll do that. Of course, that should fail. Self, let's see here. Let cursor equal self.cursor location.borrow, and then it's going to be cursor.column, cursor.row. All of that should still be okay. Now we need the ghost stone function, which is really going to be identical to the stone function, to the point that I will refactor it in just a moment, I think. So we need to set the source to RGBA. We're going to set that to 0.5, just half opacity. And because I already did all of the work to calculate out locations on the board for drawing stones and star points and whatnot, once I solve the compile errors, this should be in good shape. Self escapes the associated function. Oh, right, I can't call self. Let cursor location. Right, so like you can't pass self into the callback function because the callback function has to live for a long while. The error message is a little bit weird, except, let's see. So the callback function has the static lifetime. I'm not sure where it's getting the quote 1, but basically it's saying that like self is not going to live long enough to be used in here. So have to clone out the variables that you need. Because those clones will live long enough. Okay, we're running the loop, and yeah, there we go. We can see the ghost stone right up there. It's really faint, but it's there. So next, what I want to do is whenever this changes, I want to queue up a redraw on the drawing area. So I have to go over and look at the drawing area documentation. Okay, so GTK drawing area. Oops, wrong button, sorry. So there's the draw function. There's resize, drawing area extension. That's not it. Connect resize, yeah, no, not yet. Back up. GTK drawing area redraw. Refresh drawing area in GTK. Bunch of drawing areas, main iteration. Let's scroll down to the first question. That's a lot. Widget Q draw area or window invalidate rect. Okay. So this is GTK 3, but Oh, that's not great. Let's see about getting up to GTK4 here, since that URL didn't take me directly to where I needed to go. Go to this. GTK widget Q draw. Oh, this might actually be on the widget. Oh, it's not actually on. Let's go to the widget extension. There it is. Oops. There we go. Okay. So now we need, in order to call that, so that, like of course, these methods for widget extension are basically on every widget. So I actually want to clone the drawing area. And then on the clone in here, whoa, why am I getting a lot of error? I think because Rust Analyzer just fell behind. Dot QDraw. That might actually be everything. And I know it's going to be really inefficient because basically I'm going to cue a draw on every single mouse motion. We'll optimize that in just a moment. Okay, okay. Looks like there's some errors over here. Actually the error appears to be that I have reversed my row and column. That's great. Okay, how did I do that? The ghost stone function. Oh, the row and column parameters are exactly the opposite of what I was calling. Let's fix that. There we go. Perfect. Now, keep in mind that every single mouse motion, even though you can't see any change to the UI, I'm redrawing the UI. So I want to, I know that that's not very expensive in terms of modern processors, but you know what? I still want to optimize that. I don't want to redraw unless the actual location changes. So what I'll do is some extra code right in here. Hate it when I hit just a random thing on my keyboard. Okay, so let's do that. So if actually I could make this just a new adder. Let adder equals adder column row, and I'll grab all of that, and I'll grab all of that. And so now what I've done is I've created a new address data structure, and I can just compare it against the previous one, although I'll have to go back and add the necessary derivations to be able to do the comparison. So if cursor is not equal to adder, we are going to cursor equals adder. Actually, I think I probably need to do star cursor because these are references that I've borrowed, and then we're going to redraw. Otherwise, we're not going to. So just for good measure, I'm gonna print out a message every time the address actually changes, and thus we cue the redraw. So we're going to redrawing with cursor at adder dot row, adder dot column. And I need to get really consistent on that. Now, of course, we can't compare these two because I didn't add the correct derivations. So let's do that. This partial EQ should be enough. And it is. There we go. So I've got small motions that aren't causing a redraw, and then bigger motions when I actually get to a different cell on the board do cause a redraw. So there we go. We've got the ghost. I'm going to commit this. I only have a few minutes more before I want to log out, but there were some shortcuts, some little cheats that I made there that I want to take a closer look at. Let's see here. Oh yeah, render the ghost stone over the current cursor location. So let's take a look at that. I'm going to go up one level to the playing field. The playing field has information about whose turn it currently is. Playing field private. Of course, I'm not saving that, apparently. Good job. I want it to be able to tell the Gobon exactly whose turn it is. And I want it to be in the most elegant way possible. It might actually just be as simple as this. Although we're not using this function yet, whenever we receive an updated board state from the core, we would actually call this function, passing the new board state in. So I'm going to do that with the current player. So star self dot imp dot current player dot borrow mute equals color. We'll save that. It's going to be wrong because I haven't created current player yet, but now it's time to do that. So current player equals or is an RC ref cell color. Okay, and that kind of needs a default value. So here's where I actually am probably going to go ahead and implement. Yeah, I'm going to implement the new operation here. So fn new Gobon private drawing area is going to be just the default drawing area, same with the Gobon and the cursor location, but not the current player. Current player, I'm going to arbitrarily choose black because that's the first player in a game typically. And we'll handle these. And that should be fine. Oh, but I have to make it a ref cell. Okay, that's looking good so far. Now we come back to this. So right now there's not a way to update the playing field. We didn't actually get far enough for that to matter. So I'm just going to go ahead and start out by setting the current player. Because we're defaulting to black. Well, no, I'm not going to set the current player yet. I'm going to make sure that I'm actually using the current player to render the correct color. And since I know that we just changed it, come over to the ghost stone, and it's going to be self.currentPlayer. I am in a place where I cannot use self. Let's clone that out. Okay. It is the function expects a color, and I am giving it a reference. I might be able to just dereference that. Cannot move out. Okay, so I think the solution to this is just to add the copy trait. Like what it's complaining about here, in case you couldn't see it, is that I'm borrowing the data, and then in trying to dereference it, it's needing to move the data, or it's kind of promoting the data to being owned. And without the copy trait, the only way it can do that implicitly is by using, is by moving it. But I'm not allowed to actually move things out of that reference. So I'm actually just going to track down my color data type. And I'm going to make it copyable. So clone, copy, debug. No reason not to. In fact, I'm going to make size copyable as well. I might go through and do that with all of my view model stuff. So cargo watch -x run, and I did it wrong. Pull that up. So I'm expecting to see black stones, or a black ghost stone on the board. Awesome. Yep. Got it. So next, I'm going to explicitly set the color here as though I'm getting it from the view model. So I'm going to set the current player to view dot current player. Is that it? Yeah. So again, view here. View is the playing field view. This is the abstract data structure that I'm getting from the core. And it is currently hard-coded. It's actually hard-coded to white. So running the application right now, it's black. When I save and rebuild, then it should be back to white, assuming that this actually works. Oh. There we go. We'll do that. Nope, that's still not it. Type parentheses cannot be dereferenced. What am I doing here? Playing field private is... Oh, I probably will need to rename that. So it still doesn't like the board. No field board on playing field private. Oh, I'm looking at the wrong thing. So it's actually named a Gobon here. I've got to get that consistent. And so now it's angry because set current player. Something cannot be dereferenced. Oh, is it just that? Oh, okay. So I was adding this star here because I was seeing it in all of these. The star is only needed here as an explicit dereference because I'm pulling out a reference. Set that aside for a moment. I'm pulling out a reference and directly assigning a value to it. When all I'm doing is calling a method, it is actually not necessary to use this star. And in fact, putting the star here is the same as putting it around everything. So like set current player here, or I go from self to the what is IMP? The implementation of self. So from the playing field view to the playing field private, I grab the Gobon. So that's a totally acceptable transition. And then I'm just calling, even though, oh, actually the Gobon isn't even a ref cell. That's fun. I guess that makes sense too, because its entire state is stored internally. Basically, there's no ref cells involved, but I was still treating it as though it was. So get rid of that. And we saw very briefly when the app popped up that the color had gone back to white because, again, hard-coded that in the core. That's what's coming up in the view model. So that's pretty awesome. Making good progress here. There's a couple of other places where I've cheated that I'm not going to resolve tonight. I'm actually going to cut the stream off shortly, but I think I want to encapsulate the width and the height in fields that can be changed. So like width pixels, whatever, U32, I don't know. Not even a U32, it needs to be a ref cell because that's ultimately mutable. So I'm going to want to encapsulate that so that when the size of the board changes, that can be reflected both in the motion controller and in the drawing function. Excuse me. I feel like there's some other cheats that I want to fix. So I will do that over the course of the next week just to clean some things up. The thing is, we didn't get to this goal where clicking sends a move request to the core. Well, that's not going to happen in this stream. It's probably going to happen off camera because there's a very good chance that I'm just going to implement it because I'm actually going ahead and working on this program in between sessions. But basically, there's going to be something like I've got a click controller in here, and the click controller will, in some kind of roundabout way, where are my pipes? We'll call the core API, and it's going to dispatch, so to speak, a message that needs to go to the core. And there's a lot of work that I did figuring out how to handle an asynchronous core and the GTK main loop. Might go over that another time, might be better to just write in an article. But basically, it would be, assuming that like the core API was available, self.connect, clicked, whatever. It's obviously not the right thing. I think it's still part of the event motion controller. And it would be like api.dispatch request. So in one sense, it's going to be like request play stone. Oof. With the self dot cursor location dot row, self dot cursor location dot column. In another sense, it's going to really just be a Gobon dot or no. Oh yeah, okay. Gobon is the view model. I really should rename that. Probably just call it view. So it'd be self.view.onClick. And I somehow have to give it the parameters. So the thinking behind this is that the user interface really shouldn't be particularly intelligent. We do this all the time in 1Password, where the user interface knows that whenever you click on something, there's a particular request to be sent to the core. It just has no idea what that request is. The core told it what the request was, and it's just this opaque variable. I'm not sure how we handle it when there need to be parameters. Like if you're running 1Password and you click on the button to save an item and say there are a variety of parameters that you're saving, I don't recall exactly how we handle keeping the user interface ambivalent about what the action is while still being able to pass the parameters. So I'll figure that out over the next week and go over it. But that is where I'm going to call the stream done this evening. Switching back to my camera. I'm going to do a write-up on this tonight. It, of course, will be quick and dirty because I'm going to be doing it while watching TV. But you will be able to see sort of a summary of where the application is, where it's going, and the architecture that I've chosen, and some of my justifications for why I chose it. Like it, having the separated core and user interface is extra work up front, but makes things a lot easier if I'm planning on implementing more than one user interface. It really reduces the chance for like divergent behaviors if like the UI makes as few decisions as possible. So that is all for this evening. Thank you all for watching. If you have any feedback on it, you can leave it in the YouTube comments, but I generally don't read those. It's better to find me on the Matrix Network. Drop me a line there. My Matrix address will be in the video description. And that's it. I will be, from here on out, streaming about 8 p.m. on Thursdays. And I will see you here again next Thursday. Good night, everyone.